All right. Hello, everyone. Welcome to today's session. Good morning, good afternoon, good evening to you wherever you are. And thank you for joining us. Let us know in chat where you're watching this and when maybe if it's early for you, if it's your lunch break or your afternoon snack time break. Um, it's always nice to hear from you all. And I'm very happy today to have Pierre with me today. Pierre is a colleague at Neo4j. Welcome, Pierre. How are you doing?
I'm fine. Hi, Alex. How are you?
Good, good. Thank you. Thank you for
Hi, everyone.
joining, and thank you for doing the session today. So it's going to be a little different today with you. So usually on the Mondays we do this AuraDB database exploration. Today we have a little change of program basically, and where Pierre is working in our field team, right, at Neo4j
Yes.
in France, I assume.
Yes.
Yeah, cool. And he had the great idea beginning of the month actually to do this Advent of Code challenge on Twitter, where he put in a challenge or some kind of a coding example every day of the month until the 24th, I guess. Um,
Yes. 25th.
25th, yes, cool. Yeah, it's always difficult. In Germany, the 24th is the big day. In other countries, the 25th is the big day. So it's I get confused. Um, yeah, and this is particularly cool because it's yeah, it's a nice challenge. So how did you what did you what did spark the thought of you doing this? Why did you start the series?
Well, last year I did it in Python. And
Hmm.
so, as I'm quite new to Neo4j, like 6 months at Neo4j, I wanted to improve my skills in Cypher. Or I will tell the story of why I did that in later in the slides.
Okay, cool.
If you, mm,
Yeah, so let's dive in, right? I mean, I will put a link to Pierre's Twitter in chat in a second, so you can also explore what he did and follow along as well. But yeah, let's like you said, Pierre, let's dive in. Let's switch over to your deck. Let me get this out of the way. All right, let's yeah, here we go.
thank you, Alex. Advent of Code versus Cypher. Uh, what is Advent of Code? Alex said something about it, but it's an advent calendar with programming puzzles, and it's good to improve your skill sets in the language you're choosing. Some people use it for interview preparation, for anything, for challenge. The creator of it is Eric Vassell. Uh, it looks like that. It's a calendar with the day of the month, and every day there is a puzzle. You click on it, and you can see the puzzle. For instance, if you click on the puzzle 11, you can see the puzzle. It's like there is a storytelling, like a fantasy world. This year, it's all about submarines, and there are a lot of problems that happen to the submarine. For instance, it have to escape from caves or anything. So I can. So why would I do a full advent of code in Cypher? Of course, Cypher is not a code golfing language. It's not exactly the language you would choose as a first choice, I guess. But um, so to answer in a political way, I'd say I have a graph data science background. I'm new to Neo4j. I'm new to Cypher, and as I did it last year in Python, uh, I, uh, it was hard, but I learned a lot with it. I thought it was a great opportunity to improve my Cypher skill set, and as it's my working tool, it's important to improve it. and I wanted to have fun because it's quite fun, and I love it. And I wanted also to make evidence that Cypher is not only a query language. I call it AOC completeness. It's like Turing completeness. It's a longer, but it's about advent of code. So this is the answer, but it did not exactly happen like this. What really happened is that I did the first puzzle to test if Cypher was a good option, and because I wanted to play with Cypher, and as I have a Twitter account, as Alex said, and you can notice I'm a huge influencer on the internet. I have 19 followers. I
That will
guess.
change. That will change.
Yes. Yeah. Before I did Advent of Code, I had like 10 followers. So I decided to tweet, because I was proud of my first day of Advent of Code. It would be good for anyone to try a puzzle of Advent of Code in Cypher this year. But the thing that Twitter has is people can answer to your tweets. I didn't know. I knew that, but but some people called Michael Hunger, you may know him. I know you know him. Answered, it was a great idea, and please keep them coming in the thread. Thank you. Okay. So
pressure was on, basically.
yes, pressure on, and it was not some puzzle. Now it's 25 puzzles in the month. Okay. So this will be my December month. Storm coming and me in the garden. So okay. Challenge accepted, and here we go. I will show you some pieces of it and some graphs.
So maybe before we start this, quick question.
Yes.
Do you think this is for somebody that is new to Cypher as well, or do you think this is something for people that have some experience with it, or are there some puzzles where you think these are more easy and more entry stage friendly, and some are more advanced and more for people who have done some more things with Cypher and Neo4j before?
I was new to Cypher when I started this month. Not new, not a real beginner, but I'm on the pre-sale side of Neo4j. I know how to code. I have some experience, but I was not a Cypher specialist. So if you deep dive in my GitHub, you'll notice that the first days my Cypher was quite messy and not as good as it should be. So I'd say it's, if you're a beginner, it's even more necessary to do it. If you're already a good Cypher programming person, you may not need to. So okay. New to Cypher, you have to do Advent of Code. It's the and there is a growing difficulty in the puzzles during all the month. Not each day more difficult, but it's like this, growing progressively.
Okay. So you basically start with the first, and then you see if you are complete new, you probably will be able to go for it, and then
yes,
maybe if you already some kind of pro, then you might, you still can start at one, but maybe you want to take the more difficult ones later. Okay.
And if you're very good at it, you can try to do it like in the smallest number of line possible, or to do it very quickly. There are people that does it in 2 minutes in their language. So anybody can do it as a
speed coding challenge.
Yes.
Yeah, that's good. That's nice. Cool.
Yes, because it's a challenge too. You can there are a table. There is a table of most quick people. So here we go. So the first day was easy. I had to do a sliding window on the data. I did it as a path graph. So I wanted to be graphy. I don't. It's not always necessary, but if I can, I do it. So I did that. Second day, I didn't know there was reduce aggregator in in Cypher. So I did some. I did it with periodic commit. It was really ugly code. You won't see that if you. I won't show it to you. So I learned. Then I use APOC periodic as a while loop. I didn't know there was a for each instruction in Cypher, so keep learning. And then more interesting, this one was a bingo game against a squid, and it's the first the first very graphy problem I had with it. So I built a graph where every connected component is a grid graph, and I had to be able to match patterns of lines in this graph. So it's the first time I had to use Cypher as a pattern matching engine, and it was very convenient. So in this puzzle, for the first time, I felt very happy to use Cypher. Cypher was an advantage. It was a strength and not a weight. So it was very nice, and my Cypher was getting better. So I could do it in the nicer way. So here is the code where I make a union of two patterns, vertical and horizontal lines, and then collect the results.
How did you come up with these challenges? Did you came across some kind of a problem and you made them into a challenge, or did you think, oh, this could be fun, let's make it a challenge?
Mm, uh, I don't know. I'm not sure I understood the question.
What did basically what sparked the idea of something to become a challenge in or a puzzle for you in your advent of code? Did something, I mean, for example, this with the grid and the bingo, did you come across this and thought, okay, this is a good fit, or did you think, hey, uh, this is a good, yeah, how
Yes,
did it, yeah.
yes. The puzzle was about bingo. I had to do. There were grid of bingo, and I had to model it in my database.
Mhm,
So grid graph was the way to do it. It's not the if I had to do it in Python, I would use matrices, and I would parse it with nested for loops, and it's the way to do it in Python.
mhm.
It was not, in this case. It was not a challenge to do it as graph. It was the proper way to do it, I guess, with the tool I had.
Okay.
So. Mm. Uh, then this was a nice puzzle that I had to find some barriers, some line I had to avoid with my submarine in a grid. So I built it as a grid graph, and at the end of it, the problem was reduced to loop finding cycle finding in the graph. So it was a very nice way to reduce a problem, to run a graph problem, and this is quite interesting process. I will try to copy in some other puzzles. This one is very interesting. Lanternfish. What we have is a population of lanternfish. You may not know, but there are fishes, and they reproduce a lot. A lanternfish will be the father of a lot of other lanternfishes, and I will show you the agent. Sorry, it is the day 6. What happens is that every lanternfish has a counter that represents the days left before he creates new lanternfish. This counter is decreasing all day, and when a lanternfish is spawned, it has an internal timer of 8 and decreasing. So what I tried in the first part of it was to have one node in my graph representing every lanternfish, and with the timer decreasing each time. And when I reached the day of reproducing the lanternfish, my node has relationship to other new nodes, new lanternfish with new timer in a apoperiodic loop. And this was fine. This was fine for the first part of the problem, because the answer of it was a lot, almost 400,000 lanternfishes at the end of it. But the approach did not scale for the second part of it, because in the second part of it, I had to find the answer not for 18 days of reproduction, but 256 days. And you can see this is the answer of it at the end, and it's a big number, and it didn't scale. I could not compute it in my laptop in a convenient amount of time. So I did what I had to do was aggregating things. When some problem like this doesn't scale, there are options like memorization or aggregation of things. So what I know is that two fishes with the same timer in the same step of reproduction will behave the same way in all the history until the last day. So I can aggregate them in a single node with cardinality that I have to maintain. So what I built was this graph, a graph of what happens to a fish with counter 5. Next step, he has a counter 4. Next step, counter 3, then 2, then 1, then 0. When he reaches 0, he goes back to 6. But he also spawns another lanternfish with a timer set to 8. And then 8, 7, 6, 5, 4, 2, 0, and spawn, etc. And this is like a flow graph, but in a flow graph, there is the Kirchhoff law that says inner relationship rate and out relationship rate are equals. In this case, no, because in this node 0, there is one weight entering and two out. So it's not really a flow. It's a flow with like an amount of energy that is growing. And what I had to do is with Cypher make transaction to this graph for each step. And this is what I did. I have my the number of fishes in each in my graph at a given step, and I have to compute the next step. What I do is storing my counter in my outgoing edge. Then I do it for all the nodes, and then have to commit this. This has to be commit as a transaction, and then in another transaction, I read the sum of the counters in my ingoing relationship, and add it to my to the current number. So it's like pumping. I don't know, to the from the node to the relationship to the node, etc. And this works very nice. And I can it's day 6. So day 6 I started, but not. This is the 2 days puzzle, and this is day 6. So I had to put this in a epoch periodic iterate to make this work until the last day of generation. For instance, it may be 256, and then it gave me the right answer. So it was a nice way to do it, and to use epoch periodic iterate as an orchestrator, and working with transactional database. The next one was about crabs, very interesting, and it was another time a scaling problem. It's very often it's like that. The puzzle is in 2 parts. The first part, a brute force algorithm works, and a naive algorithm works, and in the second part, it doesn't scale, and you have to wait years to get your answer. So you have to rethink it to a better way, to a better solution. This one, day 8, was fun. It was about a 7-segment display, like 8 is like 2 squares, etc. And it was a decoding problem. It's quite messy code this time. So I don't know if it's very interesting, but there is a lot of switch case, of case when, etc. So you don't want to see it. If you want, you can go. It's,
it looks quite. I mean, in the visualization here, it looks like a very graphy application. But yeah, maybe.
Was it? I don't. It was no. It was day 10. Day 10. I don't remember.
8.
Day 8. Sorry. It's better with syntax highlighting. Yes, it was a nice graph to build, and you can go, but no new Cypher trick. But using nested case can be useful in Cypher. But then this one was very fun too. Day 9. Let me show you day 9. Sorry, my mouse is low battery. I'm sorry. So smoke basin. This is a height map, two-dimensional map with every integer you see, every digit is a height of the map. Well, no, it's a submarine map, but it's not important. The first step, in the first step of the puzzle, you had to localize the low points where every point in the every adjacent point is higher than the one you had, than the one you consider. So what I did, sorry, day 9, was a grid graph. It's easy to build a grid graph with Cypher and for each, with horizontal and vertical adjacency. The only one to consider, diagonal is not to be considered. And then I could find really easy the points where every neighbor has z coordinate, the height inferior to yours. Very easy in Cypher, and I was happy to use Cypher in this case. And then the second step of the problem, you had to count the basins. Basins are like zone in your map that are the maximal zone adjacent to only number 9s that are like a ridge. So what I did, and I was quite proud of it, is I detach delete all the number 9 in my graph. It's not easy to do this in a matrix, but in a graph, very easy. I killed them all.
Yeah, that's very clever.
I killed the ridge, and then I did a call to GDS, a weakly connected component, and boom, done. So very easy. I turned it to a graph problem.
Yeah.
Yes, it was a complicated matrix problem, but this was a boom for GDS. So high five GDS.
I think this is a very good example of where sometimes you have a graph problem, or you have some kind of connected data, or some kind of scenario, and then graphs and Cypher is super strong. And here in this case, you basically use two lines to remove the 9s, and then you have call an algorithm, and then you get your answer. And
Yes.
in other cases, like the one you showed earlier, it's quite a convoluted thing, and you have to work around a lot of issues with Cypher, because it's not really not really meant for this kind of scenario, I guess. So that's why it is more complicated. So if you have a graphy problem, then with Cypher it's very easy
Yes.
to get your answer. Yeah.
Yes. In a real life, in production, I wouldn't have removed my
No.
information
Yeah.
in my graph. I would have not detached delete the nodes, but I would have removed them in the graph in memory projection I use for GDS. So
Yeah.
don't do this at home.
Good point. Yeah, don't just detach delete.
Then this was nice because this was not really a graphy problem. This was a syntactic analysis problem. I had to day 10. to parse some words of parentheses. It's like Dick language. Parentheses has to have a match of the opposite shape, like closing, opening, closing, opening, closing, opening, closing, opening. In Python, I would have used the eval function to parse it like if it were Python, but I couldn't do this with Cypher. So what I like in this example, is that I'm very proud of this piece of code because I think it's a neat one. It's like implementing a stack with Cypher in a reducer. I have my I read a line of a word of parentheses, and I stack it with the reduce function. And you stack the opening parentheses. When you have a closing parenthesis, you pop if it's a match. If it's not a match, the word is not valid, and then go on. And it was Cypher was very comfortable, very comfortable language to do this. So I guess I'm improving my Cypher style, but Cypher can do this, and I'm
That's a
happy.
nice side effect.
Yes, I was happy to know it. Then this one was could have been hell, but I managed to do it. It's a game of life. Like a Conway automaton, a two-dimensional one. It's the 11th. Every point in the matrix is an octopus, and it has an energy level, and in every step, energy level is increasing. But when it reaches 10, it goes to 0 and gives 1 point of energy to its neighbors, to all the octopi around, and so on, until a balanced situation with no octopus with 10 points. So it's like every step you had one, and then there is a wave of zeros going around your map. And what was difficult in this problem was to manage transactions on your grid graph, and because there are a lot of nested stuffs. So what I did was the main loop where I used unwind call in transaction of 1. That is available in the Neo4j 4.4. And
just in time.
Yes, just in time for me. And inside, I had to use Apoc Cypher run many. It enables me to run every step as a transaction, and to have control of it, because when you do a call, you don't exactly know if this will be committed before that, etc. So Apoc Cypher run many gives you more control of what is committed first, then and last. But then I had my other loop, the flash loop, to do, and I where is it? It's this line with the run file. Uh, as there is a lot of strings to be managed with quote and escaped quote nested. So a good way, if you don't want to have the escaping hell of backquote quote, no, if you don't want it, you can run as a file. You can run a file of Cypher. So I run another file called flashwave.cypher with epoch periodic commit. Epoch periodic commit is like a while. It's like a while you run a transaction as long as you haven't reached an equilibrium, a balanced situation. It's the balanced situation is when it returns a zero, for instance, or nothing. And then it's another time there is a lot of calls in the commit, so it has to be transactional for to control everything occurs in the right order. So no complicated algorithm, but need a lot of control in transaction, and it was possible with Cypher and with Epoch. That Epoch helped a lot in this one and in a lot of them. This day 12 was a graph problem, totally graph problem.
So that was an easy one then.
Wait. This was a graph problem. I had to go from start to end, and I had to count all the passes between start and end. You can pass the amount of as many times as you want if the node has uppercase name, and you but only once it is if it has lowercase one. So it looks easy. It's very easy in Cypher to look for the best path, or to look for a lot of passes. But what happened is in Cypher, a pattern doesn't use twice the same relationship. So I can go start A, C, A, end if the graph is as is, because it's not in production. In a business case, it's useless to do such things. So so what I did, I could have done a complicated things in Cypher and implementing algorithm of to like depth first search or anything to explore my graph with some constraints and rules. But I wanted to use Cypher and pattern matching. So what I did is refactor my graph to make it to make a fit with Cypher. And I did that, like pruning some useless some leaves, pseudo leaves in my graph to loops, and some considering uppercase nodes as relationships. I created this kind of graph, this graph, and sorry, at the end of it, there is a very easy Cypher call to get all the passes in my graph. So it was nice to build the right graph for Cypher, because I built like a more business oriented graph, more it was fun to do.
Cool.
This one was fun too. Transparent origami. I have a big matrix of white and black pixels, and no, not white and black, like transparent and black. And in each step, I have an axis, and I have to fold my matrix along the axis, the matrix along the axis, and many times until the last one. And in the last one, I could see some code. If here is C, E, J, K, L, U, G, and J. This was what I needed to do. So as I use Neo4j, I don't want to store a huge matrix of pixels and to work on matrix. So what I did, I only stored the black pixels as nodes. And a pixel is X, Y, and the step. The first step was 0. And when I fold in each step, when I folded my matrix, I spawned from every node a next node on the next generation. That could be with the same X and Y, or with some X or some Y modified to be folded. Let me show you the code of it. So this is a folding step, and when it's along X, the X becomes two times the folding line coordinate minus the actual coordinate. So very nice to do, very nice to fold. And then I merge the new dot and a relationship from my dot to the new one, with storing the step of it. And so what I did in a very graphy way, well, I reinvent sparse matrices. I only add sparse information and not storing a lot of matrices in each step. So only concentrated in a graph useful information of important pixels, and not storing void. Neo4j is not to store useless things. So
That's very good.
a lot of us do it.
How
I
did
do.
you yeah, true. How did you the code in the end, this password basically, did that come out in the in Bloom or something, or how did
Yes,
you? Yeah.
I did this drawing of it with Bloom, with conditional coloring of the nodes. The red node is our last generation node,
Mhm.
last folding step node. So in the red node in my drawing is the last generation. A blue node is the first generation. So
Okay.
so every red node is like a hash in this drawing.
Mhm.
Yes. And yes, Bloom was very very handy to do this plotting. I love Bloom, by the way, and I use it a lot to debug and to look if everything is going fine. This yes, this one was another combinatorics hell, with very difficult to make this scale, and the code is hell. Another time, day 14, sorry. Yes, as you it's not that bad. This is part one. Part one was very easy. Let me show you the problem before. Yes. These are some rules of like a grammar. For instance, the first word is NNCB, and rules in each step and, means, for instance, NN gives C, means I have to put a C between the two ends of my first word. And so in each step, the size of the word is like twice the same as it was before. And you can imagine like 10 step, you have to the power of 10, so like 1,000 times the size of your word. But in the second part, you have to find 40 steps, and it's very big. So
Okay. Yeah.
so the common approach to some problem is a recursive function with memorization. Memorization is like if you have already called the function with those parameter, you have already the answer in a hash map, and you don't have to compute another time the same thing. Cypher is not really handy for recursion. It's not the way I wanted to do it. I wanted to do with building a graph of the first word, the graph of a second word with in between letters, and then like a fractal graph of my new generations of words. And at the end of it, it was a huge graph. It worked for the part one, but not for part two. And I had to do the same kind of thing I did with my lantern fishes. I had to aggregate something because two same pairs of adjacent letter in my word will have the same amount of descendancy, and it's a counting problem at the end. I could separate them, and the order isn't important, so I could aggregate their value. If I had two, I can sort. I have a two cardinality of this pair, and build. So at the end of it, I built a very smaller graph, and got the result. Yes. So this is the answer of the problem. So another time. In Neo4j, you have to store information and not events. You have to store only, not only, but you have to store useful things. It's as a good practice. And yesterday's problem was interesting too. It was a shortest path. Shortest path in a grid graph. So let me show you. This is a grid with a number. A digit is like a risk in a room. You don't want to have to go to a risky room. So you are looking the shortest path from from top left to bottom right. And you don't want to go to, for instance, in this 8, so 1, 1, 2, etc. So you get this less risky path, and it's a shortest path that can be done in a grid graph with Dijkstra in very easy way. So the first step is like build the graph, GDS, and boom, very easy. And the second one, you have to build another grid from the first one by copy paste it from left to right, but every digit adds 1 in each step. So and it's a circular sum. When you reach 10, you go to 1. So it's like a -1 modulo 9 and +1. So what was interesting in it here was Cypher, not really Neo4j and graphs. What was really nice was to use Cypher to build this graph, because first step was so easy. It was like GDS, boom. But the second step, I did this, and I used a lot of comprehension lists with Cypher, and it's very, very handy. You can nest them, and you can manage complicated things in a very compact manner, and it's very very nice as a developer to get more complex things in them in a recursive process of doing it. So this one is pure Cypher that helped me a lot, and it was yesterday's problem. Today's problem is like a conversion between hexadecimal and binary numbers, and with a recursive pattern of bits, and it's as a very, very complicated stuff, because I I'll show you the length of the problem. It's a very, very nice reading. So I'll need help, I think, and I'll send it on the on the Slack. Yes,
Yeah, or ask Michael.
Slack channel. Yeah, I'll ask Michael.
Yeah, he's
Everybody says ask Michael when there
yeah.
is a problem.
He put you in the place.
Yes.
Yeah.
So I reached half of my path. Oh, sorry for that.
No worries.
Yes.
No,
Uh,
that's very cool. Thank you very much,
Thank
Pierre.
you.
Oh, let's go into it again. Yeah, this is exciting, and I think this is very interesting to see how much is possible with Cypher, and how many things you can do if you know your way around a few obstacles. So it's actually very very a very powerful programming language, or it's not a programming language, but you can almost
Yes,
be. Yeah,
yes, it is.
yeah.
I'd say it is when you know some nice ways to do tricky stuff, and then it's very, very handy. Uh, I'm I'm beginning to love it.
Very good.
Yeah.
No, and I think what this showed, like what I thought, I think I said earlier, is if you have a graph problem, it all of a sudden is becoming very easy.
Mm,
And it's just a few lines where I guess I don't know, this one with the shortest path and other things. I would
mm.
imagine that if you do this with anywhere else, you have to write lots of lines.
Yes.
And here it's just a few.
Yes, but graphs are everywhere, and you have to find graphs between the lines to read graphs between the lines. But there is always a graphy way to model a problem. So uh, it's you have to practice, and then it's a way of thinking. So yes,
Yeah,
graphs graphs work.
super. No, that's cool. Yeah, I think that's the end of today. I think it's also the end of this year for us in streaming. So we will take a little break over the holidays. Well, we will be back early next year. Um, Thank you very much, Pierre, for showing us through this. I guess you will
Thank
continue
you, Alex.
doing the next few challenges, depending on your time. So
I
if you
will.
wanna
I will.
follow up what Pierre is doing until the 25th, please follow him on LinkedIn, so he becomes an actual influencer.
Yes. Thank you.
And give him some love. It's really cool. And yeah, with that, thank you for watching. Thank you for joining today. as ever, if you have anything in between the next few days, or in the holidays, if you think of something, if you wanna share something, you wanna discuss something, Discord and the forums are obviously open. Twitter is also open. We'd love to hear from you. We're looking for ideas for next year. So if you have anything you wanna share and show, uh, you know, let me know, either on Twitter or on Discord, preferably, and then we can discuss things. With this, yeah, happy holidays, happy New Year, especially everybody. Take care, stay healthy, stay safe, and yeah, hope to see you soon. I guess in January then. Thank you everybody. Thank you, Pierre.
See you.
See
Thank
you.
you.
Take care. Bye bye.
Thank you, everybody.